to lesson 28 of Industrial Automation and Control course under the NPTEL program. Today we are going to look at a very interesting topic. In the last two lectures we have seen various hydraulic system components. In this lecture we will see how they can be joined together to form hydraulic circuits for various kinds of industrial applications. So that's going to be very interesting for me, at least, to tell you. So looking at the instructional objectives, after this lesson a student should be able to cite typical industrial actuation problems, some very common problems which occur in the case of industrial systems. So then in many cases energy is very expensive, so we never like to spend energy unnecessarily. So there are various kinds of energy saving schemes, especially hydraulic systems which are very high power systems, so saving energy is important. So we will see how we can save energy for such systems, and sometimes we will find that we need to create motions using hydraulic systems. So we need to adjust speeds, we need to adjust forces depending on the requirement of the load. So how to do them? And finally all these circuits will draw using specific hydraulic symbols. So we'll see in the course of this lesson how to interpret hydraulic symbols, how to understand what components are being used, and how to figure out how hydraulic circuits work from a circuit diagram. So so we first come to our first circuit. What is that? In this circuit it is called an unloading circuit. So there are, see the circuit, there are two pumps. Can you realize that this is actually a hydraulic pump, this is a hydraulic pump, this is also another hydraulic pump, and they are being driven by a common motor. So this is the prime mover, this is the prime mover, and these pumps are actually connected in parallel. This is where it is going to the load or the system. So the pump A flow is going this way, this is a check valve. So this way is free flow for the check valve, if you recall. This is flow of pump A and this is flow of pump B. They are getting joined here, and the total flow, that is flow of pump A plus pump B, is actually flowing onto the load. Now you see, we know that what is the hydraulic power requirement? Power requirement is force into flow rate, or rather pressure into flow rate, which is equal to force into speed. So if the load force, and finally we must realize that the power comes from the prime mover, and the prime mover is designed to handle a certain amount of power. So if at a certain point of time the force requirement in the load goes up, then just to be able to, so that the power requirement does not go out of the prime mover's capabilities, so we need to reduce flow rate, right. So for heavy loads we generally move them slowly, and light loads we can move them fast, right. So what happens if suddenly the force requirement in the system goes up? Immediately what will happen is that the pressure here will tend to go up. So pressure will go up. Now you see that there are two relief valves. This is one relief valve and this is another relief valve. Now if we have decided that if the pressure goes up beyond this setting, remember that we are talking about hydrostatic pumps or positive displacement pumps generally. So as long as the speed is the same, the volume being delivered is the same, and the power requirement is directly proportional to the pressure. assuming that the volumetric efficiency is same, the leakage etc. are not significant. So, now if we want to the pressure has gone up because the force requirement has gone up. So, we want to reduce flow rate. So, what do we want to do? So, we have this setting of this relief valve as if this setting is exceeded at some point, then what is going to happen is that this relief valve will vent. So, the pump flow at that time, let me use a different color. So, the pump flow at that time, so this is the case for both pumps loaded. So, let me go to the other diagram, then we will be able to see the case where pump A is unloaded. So, then when pump A is unloaded, because this relief valve setting has been exceeded, so this is the flow rate of the pump, right, and this so this pump gets unloaded. So, therefore, the power demand on this motor reduces, and now the system is only fed from this flow rate, right. So, you see that we can unload a pump when the pressure requirement goes up to keep the power requirement. So, that if suddenly we put a very heavy load, then it will still be moved, but it will be moved slowly. This is our first example, leads to some amount of leads does not get into now interestingly, there is one point to mention, that what is the role of this check valve. See, when this pump is getting unloaded, then remember that this flow cannot go through this path, because this check valve is blocked. So, therefore, this pump really cannot unload through this relief valve. So, this pump will continue to deliver until the setting of this relief valve is also exceeded. You see, all pumps have overload protection using relief valves. So, if for some reason you have put such a heavy load which cannot be even handled by one pump, in that case this relief valve will vent and the load will of course stop and the fluid will flow like this, but the motor will be protected from overloading. So, this is the way this circuit functions. Then we go to our next circuit. We are going to see a number of such applications. So, the next circuit is where we want to in this case what was happening is that the pump was getting, if the pressure goes up, then the pump gets unloaded. But now we want a different thing, we want to select the pressure with which we want to drive the load. So, what happens is here. So, we have three modes of the system. In the first mode, the system will vent, that is the pump will be directly connected to tank, no fluid, no flow. Second is it will be operated at a low working pressure. Thirdly, it will be working at a high working pressure. So, there are three modes and we want to select the modes. So, that happens like this. So, here is the circuit first for the vent mode. So, in the vent mode, what is happening? Look at this circuit. So, what components do we have? We have the tank and the reservoir here, we have the pump, we have the motor, we have a relief valve, and this is where it goes to the system. Now, the pressure limits, the pressure up to which the system can occur will obviously be selected by this relief valve. And this relief valve actually this is a pilot operated relief valve. So, in this valve, at what is the setting of the relief valve, that depends on the pilot pressure. We have seen such valves before. Now, so actually what we are going to do is, so let us see what happens. So, how is the pilot pressure determined? So, let us look at the pilot circuit. So, this is the pilot line dashed. So, when there are this is a directional valve, right. it's a solenoid operated valve, you can see that from the symbol, and there are two springs. So, when both solenoids are off, then it is spring centered. So, both the springs will push and it will keep it at the center. What is the position at the center? At the center, it is the pump port is directly connected to the tank port. So, if A and B neither of them are energized, then this directional valve is at the center, and therefore, the vent port of this relief valve C is actually connected directly through the central position of the directional valve to the tank. So, actually there is no pilot pressure, the pilot pressure is actually a tank pressure, and therefore, this pressure is very low. So, directly the pump vents and no fluid goes to the system. So, this is the operation in the venting mode. Now, what happened in the other modes? So, let us go to the other modes. So, in the medium pressure mode, what is happening is the following. So, in the medium pressure mode, we have energized solenoid A. So, when we have energized solenoid A, we will assume that this position of the valve is active. So, now the pump port is connected like this, through this, to this and this. So, now what is the pilot pressure? The pilot pressure is actually determined by the setting of this valve E. So, whenever the pressure will exceed the setting of this valve E, the vent port will open. Therefore, the system pressure gets limited by the setting of E. Setting of C itself has a setting, its own setting, which is not it's also a relief valve. So, it has a, this is a remote pilot, but it has its own setting. So, that setting is actually higher than the setting of E. So, in that case, what is happening? So, in this case, the setting of the system pressure is actually limited by the setting of E, and E being the lower one of E and C. So, therefore, we have a medium, the limiting pressure is now medium. So, now we go to the we go to the next one, which is the high pressure mode. So, what is happening in the high pressure mode? In the high pressure mode, we are now in this position. So, in this position, what is happening? First, see that this port is actually plugged. This is plugged, means that it is sealed. So, therefore, the pilot pressure can go up to any level, theoretically speaking, it can go to very high level. So, the operation of, so now the operation of this valve is not limited by the pilot pressure, because the pilot is connected to a plugged port. So, the pilot does not vent the valve. So, now it is operated by its own setting. So, now in this system pressure gets limited by the setting of the valve C itself, and since the setting of the valve C is higher than that of E, so we can limit the system pressure to a higher level. So, you see that we are able to achieve this by either energizing A or energizing B or energizing none. So, we can select the system operating pressure mode. This is our second example. So, in the third example, we have a very common circuit, which is a reciprocating circuit. Hydraulic circuits are often required to execute cyclic motion. That is, suppose you have a cylinder, it will extend, it will push the load and it will come back, right. So, suppose some conveyor belt has brought some item. So, there may be a hydraulic arm which will push the item into the bin and then retract. So, there are now various cases. In some cases, the pushing forward is under a load, the pushing backward is free. So, there are various cases that arise, and we will see some of these, because this extension retraction reciprocating movement is a very common thing in hydraulic circuits. So, we first look at a reciprocating circuit, and in particular we look at the extension stroke first. So, here is the circuit. So, what is happening here? Very simple, again always start from the pump. So, here is the pump, the filter, this is the drain line, this is the relief valve, which is typically used for overload protection of the pump. Now, in this case, see, look at this valve. This valve has, first of all, try to interpret the symbol. The symbol has it has a solenoid, plus it has a hydraulic pilot. So, actually it's probably this direction valve is actually a very big valve. So, therefore, it is not operated only by a solenoid. The previous valve was being operated only by a solenoid. In this case, we are having a solenoid which is operating a hydraulic pilot, which is again in turn operating this big directional valve, right. And we have, in this case, we have only one this thing, only one solenoid, and the other side is. So, if you switch off the solenoid, it will come to. So, it has only two positions. If the solenoid is off, it goes to the right hand position. If the solenoid is on, it goes to the left hand position. So, now we are at the left hand position when the solenoid is on. So, the pump flow goes like this, like this, like this, and enters what is known as the cap end or the head end of the cylinder, pushes it towards left. At the same time, look at this line. This line is plugged here. So, there is nothing. This valve is a cam operated valve. So, unless the cam is when the cam is operated, it is supposed to be in the left position. When the cam is not operated, it is supposed to be in the right position. So, currently it is in the right position. So, this side is off. This side is off means the relief valve port is plugged. So, therefore, the full pressure is actually applied to the load. The pilot port is plugged, and this cylinder is moving this way, right. So, this is the extension stroke. What happens in the next stroke? In the next stroke, now we have a retraction stroke. So, what happens is when it reaches the end, it operates this limit switch at the end, at the extreme end of the extension stroke. That limit switch is actually connected to this solenoid in such a way that immediately when the limit switch is made or switched on, this solenoid is put off. So, when the solenoid is put off, this directional valve assumes the right position. So, what is happening in the right position? In the right position, the pump flow goes like this. So, now you see what is the matter here. So, in the right position, the pump flow goes like this and enters what is known as the rod end of the cylinder. So, now the cylinder moves towards the right. Note that the cam is still not operated. So, therefore, this is still plugged and this is also still plugged, and the full pressure is being applied to the cylinder, all right. So, the next case, in the next case, a very interesting thing happens at the end of the retraction stroke. That is something special about this circuit. So, at the end of the retraction stroke, when it comes fully to right, this rod is designed in such a manner that it pushes the cam. So, when it pushes the cam, this valve now connects in the top position, as we said. So, in the top position, what is happening? In the top position, this is the pump and this is the tank. So, you see that this point is very close to tank pressure. So, now the pilot port of this relief valve is actually connected. This is free flow, the direction of the check valve goes through this and comes to this point. So, the position, so the pilot port pressure which is being applied is very close to this, which is in turn very close to this. So, the pilot port is now connected nearly to tank, which means that this relief valve will now vent. So, at the end of the retraction cycle, the tank directly vents, and rather the pump directly vents to tank. So, the power required by the tank by the pump is very low. So, at the end of the retraction cycle, while it is waiting, this pump does not unnecessarily spend power. So, it vents automatically. This circuit is made in such a manner. Next, what happens? How do you start a new cycle? So, you start a new cycle like this. A new cycle is actually started by pressing a push button. So, this coil has to be connected in such an electrical circuit such that it can be switched off by this limit switch, as we have seen at the end of the extension cycle, and it can be switched on by a push button. So, every time you want to start one extension retraction motion, you need to switch on this solenoid. So, when you switch it on, again this shifts to the left, right. Now, its cam is made. So, this is in this position and this is in this position. So, now what is happening? Again this is connected to pump, this is pump now, this is connected to pump. So, now what, but unfortunately, so now it tries to flow like this, but this pressure is now so now you see again this port is actually, so the opposing force on the check valve is the full pump pressure. So, therefore, the pilot pressure, if this valve has to vent, then the pilot pressure has to cross this level, otherwise there cannot be any flow. So, therefore, this full pump pressure can be applied to the hydraulic cylinder and it will start to move left. The moment it will start to move left, this cam will be released, and when the cam is released, it will shift to the lower position, and again the vent port of this valve is going to get plugged and the cycle repeats. So, this is the way that this is a conventional reciprocation circuit. Only feature that has been added is that at the end of a retraction, one full extension under full power, retraction under full power, and then at the end when you reach the end of the retraction cycle, the pump is unloaded, basically to save power. So, let us look at the next example. Now, we want to do some special things, that is, we want to save. Sometimes it happens, as I said, that during the extension stroke you are actually pushing hard against a load. So, you want to do it slowly, while the retraction stroke is free. So, you want to do it rapidly, because you want to save time of the operation, right. So, let us see how we can do that. Yep. So, what we are seeing here, you see, again let us identify components: pump, motor, relief valve, this is tank and filter. This is a 3-position, solenoid, electrical solenoid actuated, spring loaded valve. Okay. So, and this is a flow control valve. And this is again a mechanically operated valve with the property that if you operate the switch, as long as you do not operate the switch, then this is a direct short, that is, this line is open. If you operate the switch, this line gets closed, and this switch is mechanically operated by the end of the rod, right. So, you see what is happening here. The first, what is happening is, initially again when neither of the solenoids are operated, then it is centered. So, no flow, pump gets directly to tank. Next you operate it, let us say you operate the left cylinder. So, if you operate the left cylinder, then pump okay, first let us look at the advanced circuit, which is the right cylinder. So, if you connect it, then port A gets connected to pump. So, the fluid flows when this coil is energized. So, this is for extension, and this is for retraction. So, during the extension, when this is applied, then fluid flows into this end, it comes out of this end, and since the cam is not operated, so therefore, this is a short. So, it returns directly, goes through this, returns. So, there is hardly any resistance, direct short. So, this starts advancing very fast, that is called the rapid advance. Then after a certain distance, this touches this and pushes it. So, therefore, during that time this operates and this is closed off. See, it cannot pass through this is a check valve, no flow along this. So, now the fluid is forced to flow along this. Should use a different color. So, during the forward stroke, the fluid is forced to flow along the green line, and since this is a flow control valve, so there is only a certain amount of flow possible, not more than that. So, the flow is controlled because we expect load here. So, again for power requirements we need to reduce speed. So, we are doing that by using flow control. Now, what happens when we want to have retraction? When we want to have retraction, then we will operate this solenoid. When we will operate this solenoid, then what happens is, now the, let me choose a different color, probably the blue one. So, during retraction, now this line B is connected to pump. So, how does it flow? So, it flows through this path and this path and this, now it flows through the check valve. This is the free direction, this is still off, this is still made, which means that this line is off, but that does not matter because this side check valve is free flow. So, it goes through this and it enters the rod end. So, the retraction, and from cap end it comes straight and it will go to the tank. So, during retraction, all the way, because of this check valve, fluid will always flow through this and it will have a free flow path, and there will be the flow rate is going to be high. That does not matter because the load is not connected, pressure requirements are low, and the pump can with the pump flow you can very well manage, right. So, so this is what is happening, and you can obtain a rapid retraction.